Hello. In this video, we're going to find the values of the 6 trigonometric functions of the angle alpha in standard position whose terminal side passes through the coordinate 2, -1. Okay, so we can just go through the entire, sine alpha equals y over r, cosine alpha equals x over r, and tangent alpha equals y over x. We can go through that, nothing wrong with that. So let's go with r here is equal to the square root of the sum of the squares of the components. So that's the square root of 2 squared plus -1 squared. 2 squared is 4, -1 squared is 1, 4 plus 1 is 5. So this gives me the square root of 5. And then to figure out the sine, cosine, and tangent, we just plug that stuff in. So it means that sine alpha would be y, and y is -1 over r of the square root of 5. But we don't like having the square root in the denominator, so I'm going to multiply both numerator and denominator by that square root of 5. So notice that this gives us sine alpha is equal to negative square root of 5 over 5. There you go. Now for the next one, the cosine. Cosine alpha would be x over r. X here is 2, r is square root of 5. So it gives us 2 over the square root of 5. And again, multiply top and bottom by the square root of 5. So it gives us that cosine alpha is equal to 2 square root of 5 over 5. Awesome. Now for tangent. Tangent alpha. Y over x, y is -1, x is 2. And that's pretty much it. So tangent alpha is -1/2. By the way, be very careful to not just write sine, not just write cosine, not just write tangent. Sine is never sine. Sine is sine of an angle. So you always have to have the sine, cosine, and tangent acting upon some value. It's just like with a logarithm, you can't just write down a logarithm because the logarithm is acting upon an argument. So every sine, cosine, and tangent needs an argument of its own. Okay, so those are 3 of the 6 trigonometric functions. To get the other 6, we could just go ahead and go with what we saw in the previous video, or with the definition where cosecant alpha is r over y, secant alpha is r over x, and cotangent alpha is x over y. We can do that perfectly fine, nothing wrong with that. What I want to do though is I want to realize that cosecant, secant, and cotangent are all reciprocals of their trigonometric counterparts. Now, here's the weird thing. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. And then tangent and cotangent are reciprocals. So for the sine and cosine, they're reciprocals. The other one has the co. So if you have sine, the other one is cosecant. With cosine, the reciprocal is secant. It's kind of weird, I know. So to do this, let's go ahead and start out with the reciprocal of sine, which would be cosecant, CSC alpha. Now it's the reciprocal of sine, but if you did that, you'd get -5 over the square root of 5. But we can go back up here and realize that gives us, well, square root of 5 over -1. And so square root of 5 over -1 is just negative square root of 5. Now for secant, which is the reciprocal of cosine, going back up here, square root of 5 divided by 2 is what we should get. Good. And then, of course, for cotangent. Either one works here. So 2 divided by -1 simplified is -2. And there you go. These are the 6 trigonometric functions for the angle alpha in standard position whose terminal side passes through the coordinate 2, -1. Now it's a little bit more difficult to see if we try to visualize it using a graph because it's going to look something like that, where 2, -1 is on that coordinate, and alpha is here. Or technically, alpha could be there. Either way. But that is what we have here. Alrighty, I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.